My name's Travis Foray, and I'm a channel marketing coordinator here at Red Lion. So I want to thank everyone for joining our water wastewater webinar. We're excited to share some real life application examples with you. Red Lion partners with numerous system integrators, municipalities, OEMs, and end users, providing scalable solutions to access, connect, and visualize information from virtually anywhere. So with that, I'll turn it over to Randy and Joe.
Hey, thank you, Travis. My name's Randy Nicely. I'm a sales area manager for the Ohio Valley region. I'm located in Northwest Ohio in a small town called Toledo. I cover Ohio, Indiana, Kentucky, West Virginia, and Western PA. Our first application, or our first solution we're going to speak about is something we did in Mid-Ohio for a local municipality. The issue they had was they had no connectivity between their operations and remote pump stations. We provided a scalable cellular 4G solution to connect municipal operations and manned and unmanned pump stations. The existing equipment in the control room consisted of a ControlLogic PLC, which handled day-to-day operations and eventually sent information to SCADA. There was no connectivity between the control room and the manned remote stations. The remote stations were controlled by a 20-year-old Slick 500 PLC and were in desperately need of being upgraded. Our Red Lion solution, we replaced the PLC and the I/O with a graphite HMI and our ladder logic Crimson control module, which provides IEC 61131, ladder logic function block and statement list capabilities, and gave them control and data collection as well as protocol conversion. We simply plugged in our Crimson control module to the back of the HMI, as well as I/O modules, discrete and analog, for valves on and off and pilot lights. Our graphite was plugged into one of our NT 5006 managed Ethernet switches, as well as had other components coming in that were collecting data from. To make the connection to the control room, the main control room, from the manned stations, we implemented our FlexEdge DA50 Group 1s, which gives you the capability of doing layer 3 networking, including a firewall, tunneling, NAT, whitelist, blacklist capabilities. We used a firewall, developed a VPN tunnel over a 4G connection. One nice thing about our cellular sled is that it has dual SIM card holders. Dual SIM card holders are for cellular failover. What that means is if you can have an AT&T or a Verizon SIM card in, if you lose signal or you have a weaker signal, it automatically transfers over to the stronger signal. In the man stations, we simply imported in the graphite HMI program to one of our FlexEdge DA70A Group 4 devices, which has IEC 61131 ladder logic function block statement list for local control built in. We added on discrete I/O modules and analog I/O modules, as well as the FlexEdge came in populated with a 4G cellular sled and a Wi-Fi sled, which came in handy because we have some really cool features built into our graphite HMIs and FlexEdge Group 3 or 4s. We have a built-in web server that you can view your information, either from a control room, from the local location through Wi-Fi, or when you get that call at 2 o'clock in the morning and you have a warning for a pump or some type of failure. As stated earlier, we do a lot of work with systems integrators and municipalities providing flexible solutions. This next application is very similar. And it's with a systems integrator named C2G Engineering, one I hold near and dear to my heart. I work really closely with them. They specialize in wastewater, water treatment, oil and gas, and automotive and various other markets. CDG specializes in crafting customized SCADA and control systems to design solutions to meet their customers' unique needs. They have systems that can operate as standalone control systems or can be hosted by their secure private network. The application we worked recently on with C2G was for a municipality in West Virginia. They had a need to upgrade communications and connections to remote stations and tie into C2G's hosted SCADA system, which is VT SCADA, which resides in the AWS cloud. We eliminated multiple components and put it all into one solution with our FlexEdge DA70, providing cellular access, control, and connectivity to the AWS cloud. On the upper right-hand side here, you'll see a typical installation of what C2G installs for a remote booster or pump station. There's a power cabinet and a control cabinet, as well as a backup generator. Our FlexEdge is loaded inside of the control cabinet, and underneath here, there's a dual pump system. The dual pump telemetry system handled all the information and data, which was sent to our FlexEdge. We used our FlexEdge to publish to the C2G SCADA system, which is the AWS cloud, via our MQTT AWS cloud connector. For those folks that you're not familiar with Red Lion, we have multiple cloud connectors, including Azure, Aviva, SparkPlug-B, Cumulocity, as well as a generic MQTT cloud connector. So it doesn't matter whether you have local I/O at your pump station, Modbus TCP, or Ethernet products. We can convert that and package it down and reduce the size via MQT and send it to anybody's SCADA or cloud system. With over 300 built-in protocols, Red Lion makes it easy to get information from anything to anywhere. Now I'll pass it over to Joe, and he'll run through some cool features built into Crimson 3.2, such as setting up an MQTT cloud connector, adding a Modbus device, and possibly some protocol conversion.
All right. Thank you, Randy. Give me just a moment here to share my screen. Okay, you should be able to see my screen now. Hello, everyone. My name is Joe Wagner. I'm a field application engineer here at Red Lion, and I come from an integration background. Today, I'll be demonstrating how easy it is to connect practically any industrial device to the cloud using MQTT, while minimizing bandwidth consumption and maximizing data reliability. So before I even get into that, a little bit about MQTT, if you're not familiar. MQTT is a lightweight publish-subscribe messaging protocol designed for efficient communication between devices. It's particularly useful in IoT and industrial applications due to its efficiency and reliability. Now, to illustrate this, I'll be connecting a Modbus RS485 environmental sensor to a FlexEdge DA70 on my test bench. This Modbus RS485 device is, of course, a serial connection, and we'll actually be reading temperature and humidity from that sensor and publishing that data to an MQTT broker. Now, in a real-world scenario, the broker would typically be running in the cloud or on a local industrial PC or server. For this demo, I'll be using an open-source MQTT broker called Mosquito, which is installed and running on my laptop, which is on the same network as my DA70. So I've already opened up an instance of Crimson 3.2, which is what you should be seeing here on your screen. I'll go up here to File, New, and just start a new DA70 file. So here's the FlexEdge DA70 if you're not familiar with it. This is what it looks like. I have, as I mentioned, I already have one running on my test bench. So I'm going to use this auto detect tool, which is built into Crimson, and it will automatically populate these sleds, these communication sleds, which right now it shows 3 blank sled carriages. Let's see what I actually have in there. So now that I've done the auto detect, you can see I have a cellular modem in sled 1, Wi-Fi interface in sled 2, and also a dual Ethernet sled in my sled 3 carriage. So with that, I'll just click OK, now that we have the hardware sorted out. Now here in Crimson, another thing I want to be aware of. So my device is pre-configured from a hardware perspective with more specifically the IP addresses. And I'll extract just the device configuration using this extract device configuration from device. So what this will do for me is basically allow me to avoid overriding any device level settings. So I'm just going to pull this in. Okay, now that I've done that, I can verify by looking at like my Ethernet 1 interface, for example. And I see it does have this IP address there. So I know my extract worked. So next I'm going to move straight to the Modbus device configuration. So I'll navigate to the communications category and add my Modbus device. As I mentioned earlier, this is a serial Modbus RS485 device, and it's connected to serial port 2 on my DA70. So I'll click on serial port 2. And then under driver selection, I'll click pick. Now what I'll do is search for Modbus in this manufacturer list. And as I do this, you'll see a lot of drivers. As Randy mentioned, Crimson includes over 300 industrial drivers, several of which you'll find here. But for my part, I just want to find Modbus, and these are in alphabetical order. So I'll select Modbus. And then once I've done that, I can just select which specific driver I want to use. So in this case, I want to act as a Modbus master. So I'll select Universal Master. At that point, I'll click OK. So now we can see these serial port settings up on the screen automatically. This will vary depending on the device, essentially. In my case, I'm lucky I'm able to leave this at default for this specific device I'm connecting to. You'll also see this device that was automatically created called PLC1. This is the actual Modbus device itself. So the first thing I'll do is right-click on this to rename it, and I will call this ENV sensor. Now, with this Modbus device still selected, we can see several Modbus configuration settings here in the editing pane. This is another case where these settings you may need to adjust depending on the device manufacturer of the device you're working with. Now, in my case, I'm lucky again, I can leave these at default. So next I'll navigate to the data tags category, and we'll create some data tags to actually read those sensor values. And to get started, I'll create 2 numeric data tags. I'll call the first one temp C for the temperature in my room measured in Celsius. So I'll rename this to temp C. And I reference to the Modbus register table for this sensor to find the actual register that I need. So anytime you're working with a Modbus device, you of course will have this Modbus register table that tells you which values are in which register. So in my case, I know that now. And what I can do with temp C is just change the source. And I can set this to ENV sensor. Once I do that, it's going to basically ask me which register I want to read. So in my case, I know I need to read holding register number 1. So this is OK, and I'll click OK. The next tag I will rename to humidity. This is measuring the relative humidity in my room. And I'll kind of repeat that process. I'll change the source to ENV sensor. The only difference this time is that this value is on holding register 2. So I'll click OK. And now what I want to do from this point is load this database onto my DA70 unit and just make sure these tags are actually returning values. So I will go to link update. And I'll get a confirmation pop up here. I'll click yes on. Now at this point, I don't really have anything created in this database other than the tags themselves. But what I can do is select both of them, right click and add to watch list. And then when I click view online, we can see that the values are coming in. So we're halfway there. We've added the Modbus device, and now we're reading values from that Modbus device. I'll just draw your attention to the humidity tag here. It's currently returning a value of 4,476, right around there. In the case of both of these values, there are 2 implied decimal points, which is very common in the world of Modbus. So this value of 4459, it actually is representing 44.59% relative humidity. That's just something to be aware of. And I want to mention that Crimson can account for this and display it as such. But to keep us on track, I'm going to navigate straight to the MQTT broker configuration portion of this demo, and we'll get these values to an MQTT broker. So first, I'll navigate to the communications category, where you will see our connectors. So from here, I'll click Add New Cloud Connector. And this is a good point to pause at, because I am going to be using a generic MQTT connector for my demo. But I want to draw your attention to this drop-down menu. Randy mentioned that we do support multiple connectors, which you can see all of them listed here. And I just want to mention that we can support up to 4 simultaneous connections of any of these types. So for example, I could have 4 AWS connectors active. I could have 4 Sparkplug connectors active. Those are what the current limitations are, just so you're aware. But I am using generic, so I will click OK. Okay, now I'm going to click on the connector itself, which currently has a red X through it because it's not enabled. So the first thing I'll do is enable that. Now, a couple things here. There are several settings here we could talk about, but I want to just focus on the main, sort of the greatest hits of MQTT, if you will. Number 1 is the update mode, send changes. This is where you will get some of your biggest benefits from MQTT, just by nature of saving bandwidth. So if you think about something like Modbus, it's a poll and response protocol, meaning it's constantly polling, and there's constantly responses if things are working correctly. Even if you have say you have a tank level sitting at 10 feet for 2 days, that whole 2 days it's constantly polling and responding with that current level. So this is where MQTT has, again, this is a big value add for MQTT. So if that data is not changing, we're not transmitting. So this is what the update mode is. If the data changes, then we transmit that change. This saves a huge amount of bandwidth. We can even dial this in terms of, we can specify how much a tag has to change by before we update it. So you can get really granular with it and really dial in your bandwidth savings. So I recommend using send changes, just leaving that alone. I just wanted to talk about it a little bit. Now, another major benefit you're going to get from MQTT is data buffering. So a little bit about data buffering. If I have this DA70, currently we're configuring it as an MQTT client. And let's say I'm transmitting values to the broker, some very important values we're trying to monitor over a long period of time. And let's say my connection to the broker goes down. For whatever reason, somebody accidentally cut the Ethernet cord, we lost connection. We're no longer transmitting our values to the broker. This is where data buffering comes into play. It sees the connection go down, and then it starts saving any of the data that it would have been transmitting to the broker. It starts saving that, buffering it on device. When you get reconnected to the broker, all of those changes are transmitted, and the end result is you never lost a single point of data. So these are two major things I like to talk about with MQTT, is the send changes and the data buffering. So with data buffering, I'll use 2-disk, which if you use 2-disk, it can survive a power cycle. So that's a very useful feature there. And then we have the storage device, which will be internal memory by default. Highly recommend you change that. Internal memory is it's great for testing purposes, but what I would really like to see is thumb drive or micro SD card. I prefer micro SD card since it actually inserts into the unit and it's just a little bit more secure and physically secure in that way. So I'll say micro SD card. Also want to mention that we've tested this with up to 256 gigabytes of data buffering. So with up to a 256 gigabyte micro SD card, rather. It has to be FAT32 formatted, so just be aware of that. Now, the host name here, currently you see this IP address here, that's just the default that gets created when we enable this connector. What I'll be doing is changing this to 1.99, which is the IP address of my laptop, or more specifically, the IP address of the network card on my laptop. I guess one thing to be aware of here, if you're using a cloud broker, I'm using a local broker running on my laptop. If you're using a cloud broker, one of the only changes that you'll see here in terms of configuration is the host name. This will, instead of being a local IP address like this, it will change to a really detailed URL in most cases. So just something to be aware of. Next up, we have the client ID, which is how I want to identify this device. I'm just going to call it DA7001 Joe. Next up is the publication and subscription topics. So for publication topic, I'll do topic A, and subscription topic, I'll do topic B. And so a little bit about that. So when we're talking about publishing with MQTT, we're talking about writing. So think of that as a write. If you're talking about subscribing, you're essentially talking about reading. So this is sort of another way to say read and write. So I'll leave these as topic A and topic B so we can just monitor those. The last thing I'll do here on this page is add my username and password. This is the username and password that I currently have on the broker itself. Okay, so that's it for this service tab. Now I'm going to jump to the network tab where I won't be changing anything. I just want to point something out. Currently, I'm using TCP via port 1883. We do support TLS. I just want to point that out. I'm not using it for this demo, but we do support transport layer security. Next, I'll just jump straight to tag set 1. So this is where I can actually pick and choose which tags I want to be publishing or subscribing to. In my case, I just have those 2 tags. So if I go here to data tags, I have temp C and humidity, which I can just drag and drop right into this contents field. Now let's jump back up here and look at some of these options I have for these tags. So transfer mode is periodic. You do have some other options there if you want this. If you only want to trigger a transfer based on like an alarm or a tag turning on, you have that capability. Periodic is what I see the most of. It's what I typically use when I'm doing demos, and we're going to do that. Okay. So data buffering, we talked a little bit about. This does have to be enabled at the tag level. So if we want data buffering to work with this tag set, I have to enable that. The update rate is the maximum update rate. So if these tags are changing rapidly, we will only receive updates once per second. We also have this tag writes field. So if I had tags that I wanted somebody to be able to write back to, I would have to enable this. Now, in my case, these are read-only tags, so I'm not going to even enable tag writes. But I just want to point this out to you just to make it very clear that MQTT is bidirectional. And let's see, I'm going to go ahead and just hit this lightning bolt icon, which will update my unit with this database. Okay, so now I'm going to pull up my command prompt here, which will look a little bit, well, it looks like a bit much right now because I was testing with it previously. But this is how you interact with the Mosquito broker. More specifically, I have this command down here. I just want to draw your attention to this bottom line. This command here will subscribe to any messages publish to any topic on my broker. So if I enter that, now I can see some tags flowing. And let me actually just pause this so we can talk about it. Okay, there we go. So if we look at like this message, for example, we can see our humidity value and our temp C value. Also, we get to see the timestamp for that. So as you can see, we're transmitting, and this is at a rate of once per second, which is dependent on, that's that setting I put here in my tag set 1, this once per second. And if I wanted to slow this down, I'll just show you real quickly, like humidity, we're constantly transmitting because even the smallest change to my relative humidity counts as a change. So this is where deadband comes into play. So just real quickly, I will jump to my humidity tag, and we will put a deadband on that tag. So instead of every time it changes by 1, I'll say this has to change by at least 10 in order to transmit a change. So if I update that now, we should see fewer updates specifically from the humidity tag, which we do because we can see these messages here. This only has temp C in it. This one has humidity in it. But basically every message would have temp C in it, but humidity will require a bigger change to transmit. So that's how you use the deadband feature of MQTT. Basically though, now that the data is there in the broker, the sky is the limit, right? Or if you like dad jokes, you could say the cloud is the limit. Either way, now we can easily subscribe to this data from other clients, whether those are other Redlion devices, dedicated historians, or full-blown SCADA platforms. In just a few steps, we've taken data from a very basic Modbus RS-485 sensor and made that easily accessible to powerful modern systems, all while preserving bandwidth and operating as efficiently as possible. And that's it for my MQTT demo.
All right, perfect. Thank you very much, Randy and Joe. I'm going to send out a poll here, so please feel free to answer that. And if we have any questions now, you can either throw them in the chat or throw them in the Q&A. We can get them answered. And we can enjoy a little bit more awkward silence. I know we all love it so much. Well, I'm not seeing anything coming yet, so you guys must have done a really good job at covering all that. And very detailed. All right, well, I'm not seeing any questions come in at the moment. If you do have any questions, feel free to reach out. Thanks again, Joe and Randy. Really appreciate it. And thank you, everybody, for joining.
All right, yeah, thank you.
Thank you.